Hi folks, welcome back to the third video for our 8.1 Law of Sines. And so in this video, we're going to take a look at something that is called the SSA case, all right? So this time we have two sides and the angle not in between. All right. Now, we've only done one example of the other cases, but this one is sometimes known as a plane in the, I'll let you spell that one backwards, all right? Or more formally known as the, ambiguous case. All right. And so what do we mean by an ambiguous case? All right. It means that we possibly have 0 triangles, 1 triangle, or 2 triangles. We don't actually know. Okay. We don't know until we start solving the problem. And so what I'm going to do is we're going to take a look at example 7, but instead of me jumping right to drawing a diagram, I'm going to show you a little applet that we can maneuver around and kind of get this a little bit more visually. Okay, but the numbers I want us to remember, we have an angle that's 30 degrees, a side A that's 6 centimeters, and side B is 7 centimeters. Okay. And so let's go ahead and switch screens real quick. All right, so we should be able to see on my screen right now, I've got an applet called the ambiguous case by GeoGebra. And so we had said that angle A was 30 degrees, which we can see right here. Angle B is 6 centimeters. And then we said that we saw that angle B was 7. Let's make that 7. And then side A was 6 centimeters, okay? So if we look at the way the triangle is right now, we kind of see that little a is just hanging out. Like it doesn't touch this bottom line, the dotted line, which means like if a little a was just 1.5, we wouldn't have a triangle. But let's see what happens as we change this. If I make little a 2.9, I still don't have a triangle because it doesn't connect down to that bottom dashed line, okay? But let's see if we can keep going a little bit. 3, 3.1, 3.2. Oh, at 3.5, if little a was 3.5, I would actually get one triangle, okay? But we said that little a is 6, so I'm going to keep going and make little a all the way up to 6. And one thing that we can see here is that we actually end up with 2 triangles, okay? So we can have this sort of skinnier triangle off to the left, or we can have a B2C, like the whole big triangle, okay? And so if you plug the numbers into here, you can kind of get an idea of that, but I just wanted us to think about that before we do the actual math behind the problem so we can kind of see what's happening there, okay? And so let me just reset it for a moment. Let's walk through that one more time. So I said A is 30. I said B was 7, right? And when A is just 3, I can see that that arm just kind of swings around. The leg of the triangle swings around. It doesn't actually make a triangle. But again, the moment I get to 3.5, I just get one triangle. But if I go all the way up to 6, like I wanted it to be, I have 2 triangles. It crosses at B2 and at B1. Okay. All right. So let's go back to the other share. And let's take a look at the problem again. All right, I'm going to stop this share, reshare the other one. All right. So now that we've taken a look at that moving applet, I'm going to draw what I think those two sort of look like. Okay. So we're going to start off with the skinny triangle. All right. Where angle, no, we're going to start off with that bigger triangle and kind of go from there, okay? So this one looks more like the ones that we've been drawing. Got this bigger triangle. We have our A. We'll call this one B2. And then C, just so we can match it with the diagram we saw on there, okay? And if we label this with what we have our 30 degrees, we have little a as 6 centimeters, little b as 7 centimeters, okay? And so if we go back to this idea that we have two sides and the angle not in between them, let's just prove that to ourselves. So we've got our two sides, 6 centimeters, 7 centimeters, and then we have the angle that's not in between them. We've got angle A, okay? Now, if I set up here for my law of sines, I'm going to get sine of 30 degrees over 6 centimeters equals sine of B2 over 7 centimeters, which equals sine C over C. And you'll notice that I don't have any information about C, so I can't do anything with that. But I can take these two fractions and go ahead and solve for angle B, okay? So let's go ahead and cross multiply. So we're going to grab these two, we're going to cross multiply. We get 7 sine 30 degrees equals 6 sine B2. We get sine B2 equals 7 sine 30 degrees over 6, okay? Now I'm going to pause here for a moment. Let's go ahead and just find out what this value is. I don't want us to inverse sine anything yet. We're just going to find out what sine of B2 is. And when we type this into the calculator, we should get 0.583 repeating, okay? So think back to the first video where I said sometimes our calculator just gives us one answer, right? If we type this into the calculator, we're going to get one answer, one angle that has a y value of 0.583, right? So let's kind of draw that here. We'll just draw the top half of our unit circle because we know we're only looking for up to 180 degrees, all right? And so if I were to look for an angle that had a y value of 0.5, I might have one here, maybe like here. And this would be the one that calculator gives us, but there's also one on the other side. Okay, turns out this angle is going to be our B2. This one will be our B1. Okay, so let me go ahead and type that into the calculator. Let's see what we get. We get B2, according to our calculator, is 35.685 degrees. Okay. So I'm going to go ahead and box that off because I did find angle B2. All right. So I can add that to the list of stuff that I have. I've got angle A, I've got angle B2. Now, if I have angle B2, now I can take 180 minus 30 minus B2 to get me angle C, all right? So let's go ahead and find angle C. So angle C equals 180 degrees minus 30 degrees minus 35.685 degrees. And we do all of that calculation, and we should end up with 114.315 degrees. Okay, so we've got all three angles now. Now we have two of the three sides. We need to find the third side, right? We have A and B. We need to find little c. So I'm going to be safe. I'm going to take the given information we have, and I'm going to set that equal to the c fraction so that I can find little c, okay? So sine 30 degrees over 6 is going to equal sine of 114.315 over little c, all right? And I'm going to go ahead and cross multiply. So I get c sine 30 degrees equals 6 sine 114.315 degrees. And then I'm going to divide both sides by sine 30. All right, again, being really thoughtful that we don't want to type things into the calculator right away, but we want to get this final fraction. And now when we type this in, we should get 10.936. And let's go back up and check our units. We are in centimeters for the side length. So this is going to be 10.936 centimeters, okay? All right, now all of this was just for the B2 triangle. And so I'm going to go ahead and split the page here, right? And I'm also going to take this and maybe shrink it just a little bit and move it over, give myself enough room, okay? But if you'll remember on that applet that I showed you, there was actually a second triangle that kind of looks something like this. So we have A, we have C, but it was like a really skinny triangle, and they called this one B1, okay? Now, I still have this at 7 centimeters, 6 centimeters, and this is going to be 30 degrees, okay? But how do I find out the angle measure of B1? It turns out those 4 examples we did in the beginning, that is exactly what we're going to do here. I found B2 using the calculator, 35.685. All right, so to find B2 or B1, all right, we do 180 minus B2 will equal B1. All right, so if you don't remember why, go back and watch that first video. It does explain to us why we're able to just do 180 minus B2, okay? So angle B1 equals 180 degrees minus 35.685 degrees. And we end up with B2 as 144.315 degrees. Okay, so I was able to do 180 minus it. Now let's see if we can find angle C. So angle C equals 180 minus 30 minus 144.315 degrees. And turns out angle C, and we can kind of see this on the picture here, is really small. It's a very skinny angle. In fact, it's only at 5.685 degrees. Okay. All right, now we're going to set up our law of sines to find little c, but instead of putting in sine of 144.315, we're going to put sine of 5.685. So sine 30 degrees over 6 centimeters equals sine 5.685 degrees over little c. We cross multiply. And we divide by sine 30. And then we put that into our calculator and we get 1.189 centimeters. Okay. So sometimes when we have an SSA case, we actually have 2 triangles, right? This is a case when we have 2 triangles. But like I said from the applet we saw at the beginning, sometimes we only have 1 triangle and sometimes we have no triangles at all, okay? So let's take a look at those two cases. Solve triangle ABC, given that angle B equals 73, little b equals 24, and C equals 28, right? So let's draw a diagram, knowing that our diagram might not be correct. And that's sort of the hard part. We're drawing a full triangle. We don't actually know if we have a triangle or not. Okay, so I see here that I've got my side, and I've got the angle that is not in between them. That is our pane in the SSA case, or our ambiguous case, right? And so let's just set up our law of sines and see what happens, all right? So sine of 73 degrees over 24 meters equals sine of C over 28 meters equals sine B over B, right? Now, I don't have any information about, I'm sorry, sine A over A. Ooh. Sine A over little a, right? But I don't have any information about angle A or side A. So really, I have to rely on these two pairs to help me find any information. So let's go ahead and cross multiply. 28 sine 73 equals 24 sine C. And I get sine C equals 28 sine 73 over 24. Now, I know I've been telling you, please don't just inverse sine this, but actually find what this decimal is. And here's why, all right? So sine C, when I type this in, I end up with 1.116, okay? Keep in mind, sine of an angle equals 1.116 means that there's an angle that has a y value bigger than 1. That's not possible, okay? Not possible. So in this case, we actually have 0 triangles, all right? No triangles with these numbers, okay? So you'll know pretty early on. If you get to a point where you have like sine of something equals something bigger than 1, not possible, no triangles, stop your work, okay? All right, well, what about if we have maybe just one triangle? Let's see what that looks like and how the numbers actually tell us that, okay? So same thing, I'm gonna draw a triangle and I'm gonna be okay with the fact that I might not have a picture that is exactly accurate, all right? Now I have angle C as 10 degrees, little c is 10 feet. I have little a as 5 feet, all right? And so if we fill in our law of sines, let's see what we get. Sine of A over 5 equals sine of B, of B over little b equals sine of 10 degrees over 10. Okay. So in this case, I don't know anything about the b's. I don't know any angles. I don't know any sides. So instead, I'm going to grab sine A over 5 and sine 10 over 10 to go ahead and find that angle. Okay. All right. Sine A over 5 equals sine 10 over 10. I'm going to cross multiply. 10 sine A equals 5 sine 10 degrees. And I'm going to divide both sides by 10. Sine A equals 5 sine 10 degrees over 10. All right, I'm going to put that into the calculator. See what I get for sine A, okay? And as it turns out, I get 0.0868. That's a pretty small number. That's okay. I use my calculator and I get angle A equals to 4.980 degrees. Okay. Now, if I have if I have A and I have C, I can find angle B. And if I can find angle B, then I can find little b. Okay. So angle B is going to be 180 degrees minus 4.980 minus, what was that other one? 10 degrees. And when I subtract all of those, I get angle B as 165.02 degrees. So I'm able to find an angle B. And if I can find angle B, that means I can find side B. All right. So let's go ahead and do that up here. So sine of 165.02 over little b equals sine 10 degrees over 10. I'm going to let you do the arithmetic, but you should end up with b equals 14.890 feet. Okay, so I found one triangle, but let me go back to this idea, right? Maybe I have a B1 and a B2, all right? So how did I find that last time? Once I found my B2 using the calculator, then I just subtracted it from 180 to find my B1. So let's do the same thing here. Okay, so we'll call this B2, right? So 180 minus B2 will give us 175.02 degrees, which I'm claiming is the measure of angle B1. Okay, so this would be my second triangle. But let's see what happens here. To find C, I take angle C equals 180. Sorry, this is A2, not B2. All right, so to find angle B, I do 180 minus 175.02 minus 10. And folks, we get a negative number. That's pretty sad when we can't have a negative angle inside of a triangle. So when we get to this place, we know that there's only one triangle. Okay, there's only one triangle, because even though we didn't get stuck where we did for the 0 triangles, right? We had a sign that was not possible. We worked through and we could find one, but as soon as we tried to find the second triangle, we got a negative angle, and that can't happen. Okay, so I would take some time, make sure you understand this ambiguous case. It is a little bit trickier than the others, but nothing that you can't learn. All right, thanks so much for stopping by.